Hi, welcome to the Git series of Adventurous Coder. Today we'll be talking about Git, why do we need it, where is it used, why is it so used widely, and real life examples of it. This is not going to be a one-time video, it's going to be multiple parts as Git is very vast. I will be trying to add uh, more real life topics on how I use it in my day-to-day work and how you should see yourself using it and how you would use it as well. So I'll try to get those ways and those ideas to show you. We'll start small and then we'll go big to not just simply learn about the various commands, but daily experiences and how I have seen that I have faced problems and the commands that I have used, and also my other peers, the problems that they faced and the commands that they used to get out of those issues as well. Now, to understand Git, first we need to understand version control and why do we need it. Well, when I say version control, it just means, well, it's a version of your code base. It's to track and manage the changes that are happening. Now, to explain version, it's like a season. Rather, let's make it like a TV show season. So, your initial code base, season one, deployed to production, people are using it. Now, you're working on season two, but you don't want people to know about it. So, you're going to use version control to write it, and season two goes to production. But say season two failed, and you now want people to go back watch season one. You you use version control to go back to the previous timeline. So it's sort of like a timeline management system. Um, Also, that's a very good analogy. Actually, just came up. That is, think of your entire life as a timeline, and you can pick a particular time in that frame, the checkpoints, and go back to that particular event. So it's that is what it means to have a version control system. Why do we majorly need it? It's to allow, you know, coordination, sharing, and collaboration between team members. When you're a sole developer, you have one project, you have a folder, and you make changes to that files. Great, amazing. But if when you have multiple people, you will be working in a team as a software engineer, you'll have 10, 15, sometimes there are 300, 400 people working on the same code base. Then how do you ensure that we know what changes are going in, what changes have been made by who, which should be going in and not? How do we revert our changes or go back to a previous good state if there was a bad change sent to the production? So version control helps us with a lot of these things. I know that some of these do not make sense right off the bat, but they will when once you start using Git and slowly you get experience of it as well. Well, what are the different kinds of version controls? There are many. Git, Mercurial, SVM are common ones. Let me open the links. So Git, then there is Mercurial, Mercurial, and SVN. So Git is very common. You might have heard. Well, that's how the video started. Mercurial and SVN are also used, but they are quite old version controls system. They are open source, but some of them are paid versions, and there are differences between all of these versions as well. But it's not like they don't exist anymore. They are there. They are still used, um, but not as widely as Git. So what is Git? Git is a free open source distributed version control system, which is, like what we just explained. So Git it is faster. That is what Git is. It is much faster and efficient with respect to other version controls, and it is a FOSS. FOSS just means free open source software. So it's not paid software. It's open source does not always mean it's free, but FOSS means it's free open source. Uh, Many developers have done great things on it, and that's why it's very big today, and that's why we're going to go with Git. Well, there are other reasons for why Git as well. Very common ones being very widely used. I think I have majorly heard all of the developers or software engineers today widely use Git and be like, okay, I use Git. I am familiar with Git. That's why major companies have also moved to Git as well, because people already know you don't need to train software engineers on it, and that makes it easier. Like, oh, I don't have to train an engineer. He can come in and start using something right off the bat, so I'm going to use it. It's easy to use. Well, with respect to other commands or other version controls, um, Git is very easy to use. The commands are very easy to understand what they do. Some of them not right off the bat, but over time, once you use it, yeah, it makes sense. Uh, Git is also faster than other version controls, very much faster. That is like 50 to 80% difference. Well, thanks to the algorithms and everything that Git uses, and the software that Git makes, and the way they manage it. Git also offers various different features than the other version controls, like branches, merging, rebasing, quite a few. These do not need to make sense at the moment, uh, but yeah, just Git is very powerful. There is an about page as well for Git where they explain much more information about why Git is better than the other open source or even paid version controls. You should go through it. Uh, it's not like someone's gonna ask you, do you know why Git is better? But knowing it definitely helps. Okay, so now let's understand the Git workflow. So the first, this here I'll just be talking about some terminologies in the workflow as well. The first terminology you should understand is a repository. What does repository mean? Well, it's the source code files that you have, the folder, or rather locally you call it a folder. But if I want to talk in terms of a software engineering term, it's gonna be a repository for me, or a short form repo, REPO. So you would have heard people say, I'm gonna clone this repo because repository. I'm gonna push to that repo or repository. That means they're just talking about the folder where our entire source code files are. Some more terminologies that you should understand for Git is, and they work in this manner, is the working directory. That is your local folder where you're doing your changes. So you have a folder, you have a file, you wrote some piece of line of code in it. So you have done a change in your local working directory. That means this is the working location. Then you have a staging area. That just means you did some change in your working directory and now they go to a staging area. That means Git is aware that these changes are clubbed together and make one particular event in the timeline of this code base. Then comes the local repo. So the files from the staging area move to the local repo. Local repo means the local repository. That is how Git manages your folder, local folder as a repository in your system itself. Then comes the remote repo. So now you have the files in your local system, yes, but you're collaborating with team members and you want this code to be pushed to production, which is not on your local server, not on your local system. They're somewhere remote, some Linux server or some AWS ECS service, but yeah, they you need to send these changes there, and there is a copy of the same repository present. That is their local repository, but in our sense, that is the server. So we're going to call it the remote repository where we store all of our changes. So that's the remote repository that's present in some XYZ place away from outside of our local system, and we call it the remote repo. Okay, let's go ahead and install Git. So there is a Git's download page where you can install the GUI version of it, or you can also install directly the Git. You can install Git via Git itself. Um, there are other various ways to install too, like using sudo apt, wget, many more that are present for different kind of devices, Linux and Unix. For Windows, there is one majorly, that is GUI, but you can also use WinGet. You can choose your preference on how you want to download Git. Now time to Get it? Get the pun? Let's get it. Okay, sorry, dad jokes. I don't know why I wrote it, but yeah. First, let's go see how our Git terminal looks like. Well, this is our Git GUI. Let me open it again. This is a Git bash. We opened it. We can also write it in the command prompt of Windows. If you have Mac OS, you can open item or the terminal, whatever you use, and it should be very much similar as Git bash. So that's why I'm going to use Git bash to ensure every all of us know what we are doing and there's no confusion. So once you install Git, there's some initial things you should always do in a new system. Now, right now, this is a Git which is very, new, fresh, does not know what it is, does not know who you are, what it needs to do. So you're gonna tell Git first who you are. So that is gonna be git config global. Config means configuration. Global means it's set for anywhere you use Git in the system. My name, user dot name, is going to be, well, I'm just gonna say adventurous. I'm too lazy to write it entirely. Then I'm gonna do git config global user dot email ac@gmail.com adventurous coder. Uh, it does not validate any of this information. It just consumes whatever you say. So that is another good thing. You can assume yourself as someone else, but not really. We'll come to that part later, how remote repository would like to verify you. That's a conversation for later. So this is it. I'm not use my real name, my email. I will use it for the later videos, but right now I'm just showing it to you guys. Okay, now we have told Git who we are. Let's move on to the next part. The next part is to create a repo. First, before going to create a repo, let's create a folder, or let's say a Git repo. Now we are going to go into the Git repo. So initially this repo is empty. We are gonna tell Git, like, the folder name is this Git repo does not mean that it's been made as a repository. To make it as a repository, we are gonna tell Git init. Init means initialization. So I'm gonna tell Git initialize yourself here. Understand that this directory or this folder, which is my working directory, is now a repository as well. So now Git has initialized. You can see there is nothing, but now if you do all, that is .git folder. Now that this .git folder contains various information that's relevant to Git for version control as well. You also notice this master beside it, which means this is the master branch. Well, I have a very old Git version installed. Uh, for anyone who's concerned, master is no longer an inclusive word. This has been renamed to main. Once I update my Git, this should get updated as well. Going forward, it'll only be a main branch. But yeah, so it's going forward. It's called main. You should be seeing main here instead of master. That was for a that was to avoid master slave terminology present. Okay, now we have created a repo. Let, let's check the status of the files. Well, we can't check the status of the files because, well, we don't have any. Let's just create one, that is readme.md. Now let's see, we have a readme file. So how do we check the status of this? Get status. I'm not sure if that was visible, but yeah, let me just do a get zoom in. Okay, we see status, that is means these are untracked files. Untracked files are just the files which are in your working directory but haven't been staged yet. If you recall the terminologies, these are the working directory files. So I create a readme file. Now let's go to the staging area. That is get add no get add. There are multiple ways you can add files to the staging area. Either you can mention the file name itself, or if let's say there are multiple, there was one more, you can mention them with space, or you can mention dot. Dot means every untracked file in this working directory at the moment. So I'm just gonna do get add dot because again I'm lazy. Now let's check the status of it. It says changes to be committed. That means they are staged at the moment. So they are ready to be committed to the local repository. Okay, let's move on. Now time to commit changes. Can't get someone to commit though. Okay, Git is the only commit. Dad jokes, please ignore it. Let me write this. Git commit. Again, I can use the same way. Either mention the file or mention dot. Dot means all of the staged files in in this working directory or the repository present here. Commit just means, well, the staging or the local repo have two actions. Now you did a git add to move from working directory to stage. That's like an in between. It's the files are in between. They are not exactly a working file, but they are not also set to the version control that this is a event that's going to happen or record this as a event in its timeline. So we're just gonna do a git commit to tell now it's time to record this event in its timeline. I do a git commit dot. This opens me an editor. Here I write the message. Initial file readme. Now there are much more things you should consider while writing this message. I'll come to that in later part of my videos when I talk about software engineering in general, uh, on how you should have your commit messages, the details present, etc. But yeah, for now, let's just write initial file, readme. I do this, it's committed. Now let me type git status. There is no file in the working tree. That means that I don't have any unknown changes to the git. For additional here is you saw the editor that opened to type the message. I set it by using git config global, oh my god, code.editor as Vim. You can change it to Emacs or anything that you feel is good for you, but I am more comfortable with Vim, so I use that. For commit, there is one more shortcut that you can use. Let me open README and make a change in it. Oh, this is a change. I know git status. Let's check it. Well, this time it's not untracked. You see, it says modified because last time it said nothing, but this time it said modified because now Git is aware of this file. It knows that this is an event that has already happened and we are going to change something in this file. So that means there's a history of this file present as well. Uh, then I do a git add dot, let's check. Well, yes, it's in the staging area. Now let's commit it with the message as well. Second commit, updated readme. So it didn't open the editor. I directly use -m to say what the message is. So this way I save my time. If my message is short enough, I can use here directly. If my message is slightly longer and I need an editor to, let's say, next line, more details, I'll open the editor. That's it. That's on git commit. Let's now check how to check the history. So as I said, version control maintains a history of your files. That means there's a timeline. That means there's a way to even check this timeline, right? So let's go to get log. Now this tells, well, this for on by admin code, this is the email ID which we initially set. On so and so date, I committed my first I committed my first change, which has a unique identifier. So this information is a commit ID. That UUID that you see 646. This is a unique identifier for my commit ID. So this ID will be common across code bases. This will not be repeated again. So that's what it means to have a UUID in itself. Um, but yeah, now I know that this commit ID refers to in my Git repo, my this change of initial file readme is reference with this commit ID. Then I did my second commit by on, well, within 2 minutes, and there is a new commit ID for it instead of old one. So now I know to reference my previous timeline history where I didn't have this change, that is the initial file, and now I have a new event in the timeline, that is this new commit ID where I made a change in the readme. So that is it for Git. As of today, this is the first part of the series. There is more to Git than this. In later videos, I will show how to check the differences between two different commits, uh, or to how to push it to a remote repository, how do software engineers use it again in remote repositories, because these are local changes. As a software engineer, you'll always have a remote repository present. So how do you use that? What are the common things that are there? I have not entirely laid out a plan for it yet, but I will go ahead, try to sort it out as nicely as possible in ways I learned it as well. To and if you have any more questions or you want more details about certain things, drop a message in the comment section. I'll try to accommodate my in the upcoming videos wherever it fits right, or if required, I'll try to create a separate video for it itself. Thank you for watching this. Like, comment, and subscribe. In comments, please give feedback on my videos, what can be made better. And that's it. Thank you for watching this.